if the clock model works better for you or for it or the money model, because one will be better than the other. So here's our first problem. And sometimes they both work, but ultimately it's up to what works better for you. So here we have a half and a fourth. And now some of them, you don't need any model. Do we need a model for this? Necessarily? Yes or no? Why not, Clara?
Because automatically you think of 2/4 and then you just subtract 1.
Yeah. Most of you can just say that this is a fourth. It's not too difficult. But if you do need a model, how much money is 1/2? Pitch? 50 cents. Let's write this down, folks. Minus, what's a fourth of a dollar, Doherty? No, not what. What's a fourth of a dollar? Revel. Fensky. 25 cents. And if we take 25 cents from 50 cents, we got how much cents? Yep. 25 cents. And what do we have to write 25 cents as next? A fraction, which would be what? 25 hundredths. And then we're not leaving it that way. What fits into 25 that also fits into 100? Yeah, but that's not very big. We want the greatest common factor. Slinky. Nope. She just said that. The greatest common factor down in front.
10.
10 does not fit into 25 equally. Got to work on your division facts. 25. 25 divided by 25 is 1. And what's 100 divided by 25? 4. Yep, that's the money model. Let's see if the clock model works. Now, we're not going to draw the clocks. I just want you to think about the times that they represent. So half of an hour is how many minutes? What's half an hour? Rev? 30 minutes. What's a fourth of an hour? How many minutes? How many minutes? Moose, how many minutes? Half an hour and a fourth. Fourth of an hour. How many minutes? 15 minutes. Remember, folks, you can look right up there if you ever need to. We got a fancy old clock. And if we take 15 minutes from 30 minutes, we've got how many minutes? Viv? What? If we take 15 minutes from 30 minutes, we've got how many minutes? 15 minutes. Very good. And then we have to change that to what? We got to change it to a fraction because 1/2 minus a fourth isn't 15, is it? That makes no sense. So what do we write that as a fraction? 15 over 60. And then we reduce. What fits into 15 and 60 equally? Hallie? It does, but there's something bigger. Yep. 15 divided by 15 is 1, and 15 fits in there 4 times. So both models work. The money and the clock. Sometimes they both work. Sometimes they don't. Let's try another one and see if there's a preference. And again, if you don't, if you can just do it in your head, that's fine, but make sure you can back it up. Let's try this one. Read this one for us, Zach.
3/4 minus 1/5.
Very good. Now, is there a model that would work better, or do they both work? Do you have a preference? What do you think, Trev? What's that? The money model?
Yeah.
Okay. Would clock model work?
Yes.
It wouldn't? Well, I hear yes and I hear no.
I think it would.
Do we know what a fifth of an hour is? We do, right?
Yeah.
How many minutes is a fifth of the clock?
12.
12? Yes? Does 12 fit in there 5 times? Yeah, so we could do both. Let's do the money model. What's 3/4 of a dollar? Anybody? 3/4 of a dollar. 75 cents. Minus a fifth of a dollar. Remember what goes into a dollar 5 times? Not a coin, but an amount. We've talked about it several times. Close. A little lower.
5,
Not that low.
10,
A little higher. 20 cents. Yep. That's the one we forget about because it's not a coin. And if you take 20 cents from 75 cents, how much have we got left? How much have we got left? Moose?
55
55
cents.
cents. And then we rewrite that. What's 55 cents become as a fraction? Aubrey?
5,500.
55 hundredths, and then we need to reduce it. What's the GCF of 55 and 100? What's the biggest factor that fits into both of those? What number times another number fits this? Fitch? 5 does. Any others?
11.
11? Does 11 fit into 100 equally, though?
No.
No? Slinky? Okay. Down in front?
10.
Does 10 fit into 55 equally, though? No. So let's go with 5. 55 divided by 5 is 11, and 100 divided by 5. So we end up with 11 twentieths.
That's what I was thinking.
And the clock model would work also. Let's try the clock model. What's 3/4 of an hour? How many minutes?
45.
45 minutes minus how many minutes? What's 1/5? Like we already said it, what number goes into 60 5 times? It's a little weird, I know.
12.
12. 45 minutes minus 12 minutes is how many minutes? Yep.
33.
33 minutes. And then we have to write that as a fraction. 33 out of what? Rev? 60. What's this going to reduce to then? I mean, we all know it should reduce to this because we just did it. What fits into 33 that fits into 60? What number fits in there equally? Any double number like that, you know it's always going to be what, you guys? What's it always going to be?
5.
No,
11.
11, right? How many times does it fit into 33?
3.
How many 11s fit into 60? Any? I can see some strange looks. Does it work? So it can't be 11. What would?
7.
Well,
No. Don't think, you're thinking too hard.
7. 13.
No, you're thinking too hard. Ella,
3.
3. 33 divided by 3 is what?
11.
And 60 divided by 3 is 20.
I guess it is the most childish answer that I thought it was.
Good. All right. I want to try one. Let's try. Ooh, this is a good one. Separate it. Let's do 2/3 minus 5/12. Would one model work better than the other for this one? If we have 2/3 and 5/12. Which model? What do you and your neighbors think? Ask your neighbors, see what they think first. What do you think?
12.
Ella, what do you think? Yep. Why not money? Who can tell us why the money model won't work, Trev?
There isn't really a 2/3 of a dollar.
Yeah, you can't split a dollar into thirds equally. So 2/3 of the clock, how many minutes is that? Think, how many minutes is 2/3, Fensky?
20.
That's a third. That's 1/3. What?
40.
40 minutes. So 40 minutes minus, what's 5/12? 5/12. Fitch? A whole? Nope. 12/12 would be a whole.
25 minutes.
5, 10, 15, 20, 25 minutes. Because remember, 5-minute sets fit in there 12 times. 5 fits in there 12 times, and 12 ironically fits in there 5 times. Subtract that, and how many minutes have we got? 40 minutes minus 25 minutes?
15.
Yes, no?
Yes.
Slink?
15.
15 minutes. Then we write that as a fraction. 15 what, Doherty? No, the other Doherty. Yeah. No, we're doing the clock method. Hallie? 60th. We've done it 3 times now. 50, 60th, 60th, 60th. And we already did this one, so we can look. Just reduces to a fourth. So if Chase has 2/3 of a pizza, and Aubrey and her friend eat 5/12 of it for some weird reason, he still has a fourth of a pizza left. I don't know who goes and eats 5/12. You eat a slice. You usually eat an eighth and an eighth and an eighth. Question?
Doesn't 3/12 work for this also, right?
For the clock?
No, for like 3/12, okay, you can get that as an answer.
Yeah, yeah. But it would be bigger. We don't want bigger. We want smaller. We want to reduce.